In this video we're going to use the definite integral to find the area between a curve and the x-axis. So we have drawn below here to the left the function y equals 2 minus x squared. And we should notice that this function intersects the x-axis at this value right here. We can find that value by taking 2 minus x squared and setting it equal to 0, and that gives us x equals plus or minus the square root of 2. Since we're only interested in the part of the curve to the right of x equals 0, we only want to put this one value, or we only need to put this one value, square root of 2, on our graph. That's where it intersects the x-axis. So that divides the graph into two regions. One of them has a purple shading and the other has the turquoise shading. And so what we want to do is find the area of those two shaded regions. Notice that if we were to find the integral between 0 and 2 of 2 minus x squared, we would not be finding the area that we want. And that's actually not so easy to see, so let's point out in more detail why this integral right here does not give the correct area. So we integrate it, we get 2x minus x cubed over 3, and we're evaluating that between 0 and 2. And as you see, we've done that calculation, and that gives us a result of 4/3. Now let's separately calculate the area of the purple shaded region and the turquoise shaded region. Okay, so going through these calculations for the area of the region that's shaded in purple, we are integrating between 0 and the square root of 2. When we do that, you see that we get an area of 1.88. So this region here has an area of 1.88. To find the area of the turquoise shaded region is a little bit more difficult because we have a bottom limit and a top limit, and neither of them are 0. So we go through the calculations, plugging in a top limit of 2 and a bottom limit of square root of 2 on this next blackboard, and we find that we get an answer of negative. So if we look back, we see the region is below the x-axis, and that is actually why we have a negative answer, but the area would be positive, so we just change that negative over to a positive. And if we add these two areas that we've gotten, the 1.88 from the purple shaded region, the 0.55 from the turquoise shaded region, we get a result of 2.43. And so we compare that to the result that we got by just integrating across the whole region from 0 to 2, and we got, as you recall, an answer of 4/3. The difference between the two answers is that this 4/3 right here is actually the purple area, or purple region's area, minus the turquoise region's area, whereas this answer right here, the correct answer is the sum of the two areas. Notice that if we take the 0.55 away from 1.88, that would give us the 1.33. So the correct answer is 2.43, the area of the two regions added together. The point of this video is to show that when we have regions above and below the x-axis, we have to calculate their areas separately. We are not allowed to do this in the easier way of just integrating 2 minus x squared across the whole region. When we do that and get this answer of 4/3, it finds the difference of the two difference of areas above minus areas below. So this concludes this video, an example of calculating areas between curves and the x-axis when that curve falls, or that curve is both above and below the x-axis.